All right, year 10. So today we are looking at sketching quadratics using turning point form. So we have a quick recap of all the concepts we've covered so far. We have our turning point form of a quadratic equation where h and k form the turning point. The axis of symmetry is x is equal to h. A is your dilation. Remember, if it is greater than 0, then the turning point is a minimum. If it is less than 0, the turning point is a maximum. Furthermore, if a is greater than 1, the graph is thinner than x squared. And if a is between 0 and 1, then it is wider than x squared. Finally, if a is less than 0, the graph is reflected in the x-axis. All right. So looking at our first example, determine the coordinates and nature of the turning point. Now the word nature refers to maximum or minimum. Okay, so those are the two that we'll be looking to identify. Looking at A, we have y equals -4 outside of x minus 3 squared plus 6. So the first thing we need to identify is what is h and what is k. If you look at our standard equation in turning point form, we have x minus h squared plus k. From this, you can see that h is equivalent to 3. So h is equal to 3 in this case. Your k value is equal to 6. Therefore, your turning point is equal to hk, or in this case, 3, 6. Its nature is found by looking at your a value. Your a value here is -4. Now remember, if a is less than 0, then it is a maximum. So our turning point in this case is a maximum. Looking at example B. Again, I'm going to write the turning point form beneath it so that I know exactly what h and k are. Now, you'll notice here that minus h is equal to +3. If ever you are in doubt, set it up as an equation. Minus h is equal to +3, in which case h is equal to -3. My k value is -4. So my turning point is equal to hk, which is -3, -4. Now this does not yet tell me the nature. The nature, I have to look at my a value. And here I can see that my a value is +9, which means that this is a minimum. As a is greater than 0. Next, we're going to look at finding the x and y intercepts. Now, the x-intercepts, we're going to be using a lot of our work from quadratic equations in the previous unit. The y-intercepts are fairly straightforward. To find the y-intercept of A, we're just going to let x equal 0. Okay? So just to remind you, this is for the y-intercept. When we let x equal 0, y is equal to 0 plus 4 squared minus 16, which is 4 squared minus 16, which is 16, take away 16, which is 0. Now what that tells us is that when x is 0, y is 0. That is our y-intercept. Now, please always write this in coordinate form when you're asked. Our x-intercepts, we're going to solve this quadratic equation when y is equal to 0. So for our x-intercept, we're going to let y equal to 0, which will give us 0 equal to x plus 4 squared minus 16. We're going to use our DOPS working out in order to factorize this equation into two binomial products. So we get 0 equals to x plus 4 plus the square root of 16 times by x plus 4 minus the square root of 16. Now this simplifies because the square root of 16 is 4, so we get x plus 4 plus 4, x plus 4 minus 4. Simplifies further, we get x plus 8 multiplied by x plus 4 minus 4 is x plus 0, which is just x. Now, using our null factor law, we can say that x plus 8 is equal to 0, in which case x is equal to negative 8, or x plus 0 is equal to 0, in which case x is equal to 0. Now, we would expect one of our intercepts to be x equal to 0 because we know from our y-intercept that it passes through the point 0, 0. So again, we're not going to leave these as they are. We're going to put them in coordinate form. X-intercepts are negative 8, 0, and 0, 0. Now, moving on to example B, we have y equals x plus 7 squared. We're going to use the exact same working out. We're going to, for our y-intercept, we're going to let x equal to 0, in which case y is equal to 0 minus 7 squared, which is just minus 7 squared, which is 49. So our y-intercept is 0, 49. Our x-intercepts, we're going to let y equals 0. In which case we will get 0 is equal to x minus 7 squared. When you square root 0, or when we expand this into binomial products, we get x minus 7, x minus 7. Null factor law tells us that x minus 7 or x minus 7 must equal 0. That only leaves us with one solution, which is x is equal to 7. So our x-intercepts, there's only one, and that is 7, 0. When you're sketching quadratics in turning point form, determine the basic shape by looking at your a value, find the turning point by looking at your h and k, then find your y-intercepts and your x-intercepts. You must always label. Always label. Those three things. You must always label the turning point, the y-intercepts, and the x-intercepts. Looking at example 3, we have y equals x plus 4 squared minus 9. I'm going to write your turning point equation beneath it. All right. So from here, I can straight away see that I have an a value of 1, which means it's going to have the same shape as your y equals x squared parabola. I can see that minus h is equal to 4, in which case h is equal to minus 4. And I can see that my k value is equal to minus 9. From this, I know that my turning point is -4, -9. And from my A value, I can tell that it is going to be a minimum, as A is positive. That leaves me only with finding my X and Y intercepts. My Y intercept, we're going to let X equal 0. In which case, 0 plus 4, Y equal to 0 plus 4 squared minus 9. Y is equal to 4 squared plus, minus 9. It's equal to 8 minus 9, which is in fact 16 minus 9, 4 squared being 16, which is equal to positive 7. So my y-intercept, always write it as a coordinate, is 0, 7. X-intercepts. We're going to let y equal to 0. 0 is equal to x plus 4 squared minus 9. We're going to use factorizing through difference of perfect squares. We'll get x plus 4 plus root 9, x plus 4 minus root 9 equals x plus 4 plus 3, x plus 4 minus 3. Simplifies even further to x plus 7, x plus 1. Now from this you can set up your equations, or you can simply say that x is equal to minus 7 as your first intercept, x is equal to minus 1 as your second intercept. So your x-intercepts are minus 7 and 0, and minus 1 and 0. I'm going to go ahead and plot these now. So minus 7 and 0 and minus 1 and 0. That's my minus 7. That's my minus 1. You'll remember that my turning point is minus 4 minus 9. So that is found at minus 4 minus 9, which is this point here. The turning point should always be halfway between your x-intercepts. The only other thing I need to plot my parabola is my y-intercept, which is at 0, 7. 1, 2, 3, 4, 5, 6, 7. Here we go. 0, 7. I now have more than enough points to plot my parabola. I draw it down through my x-intercept, create a nice curve, back to my other x-intercept, and that is my graph of y equals x plus 4 squared minus 9. For the second part of these notes, please see the next video.